Hello, Math B Honors students. Uh, Today our lesson will be the 1.1b lesson, Linear Expressions and Real-World Contexts. It's a pretty short lesson, and I think it's pretty straightforward, and let's just go ahead and get right to it. Um, Linear expressions can be used to model many real-world contexts. For example, if you buy 3 pieces of chicken that cost X dollars each, a slice of pie for $3, and a drink for $2, we can write an expression that represents the total amount you spent, 3x plus 3 plus 2. The simplified form of this expression would be 3x plus 5. Okay, remember that we always put variables first. We put the constants simplified at the end. Okay, so that was just an example. So let's go ahead and practice number one. A salesperson gets a base salary of $300 per week plus $20 for each item he sells. I like to highlight words like each because that kind of tells you that it's a rate. He sells X items in 1 week. The salesperson also spends $40 a week on travel expenses, right? Okay, so it says identify the unknown quantity. Write an expression that represents the total amount of money that the salesperson had at the end of the week. Okay, so it's important that we realize that this salesperson gets money, $300. You get $300 every week, and you get $20 for each item he sells, right? So let's first define X as amount of items sold. We don't know what that is. And we get $300 plus $20 times every item. Okay. He sells X items in 1 week. So that's kind of like what we should underline. We then have to subtract $40 because that is kind of like your cost of operating, right? Your operational costs. You have to spend $40 a week on gas or airfare, whatever the case may be. So you then want to simplify this. This is not simplified because we know we can make the constants combine, and we get 20x plus 260 as our final expression. Really depends on how many items you sell. So if the salesperson sold 50 items, how much money did he earn at the end of the week? Okay, so really they're just asking you to plug in the 50 into X. And I think some of us are capable of doing this, but I'm going to go ahead and show every step. 20 times 50 is 1,000. 1,000 plus 260 is going to give you a grand total of $1,260 for the week. That's a lot. It's a good amount, right? Depending on what this item is, right? Can you really sell 50 in 1 week? That's kind of like selling 7 in 1 day, right? So certainly possible. Certainly possible. Okay. Let's move on to the next question. Okay. So at any point, class, if you feel like you want to pause the video or you want to take a look at how we did it, um, it is to your benefit that this is a video recording. Now, remember, class, let's review what I did. Every time you have a word problem like this, you want to make sure that you define your variable. You want to make sure that not only you, but the reader, the audience, knows what your definition of the variable is. Then you want to follow the context and just create an expression, and you get something like 300 and negative 40, and then you have the variable 20x, right? Obviously, you want to combine the expression to make it simpler, and this is our simplified version. So you get something like this. Once you have the simplified expression, you then can answer other questions regarding the same context. Like if you sold 50 items, how much would you get? Well, I could also say something like this. If I earned, or this person earned, $1,560 in 1 week, how many items did this person sell, right? You can go reverse. This is kind of like the straightforward way to do it. If I sold 50 items, how much do I make? But I could also say, if I made this much, or I need to make this much, how many items must I sell? You can see how math can go forward and it can go backwards. Okay, so let's take a look at number 2. Number 2 says, Tim took his friends to the movies. He started with $40 and bought 3 movie tickets that each cost X dollars. He bought 1 tub of popcorn that cost $5.75. So, got to realize that spending money is taking away from your total amount, and you start with 40. So identify the unknown quantity. The unknown quantity in this case is how much the cost of each movie ticket is. So let's go X equals cost of movie ticket. And we don't know how much it is, but we do know it costs a certain amount. And in addition to that, we know that Tim started with $40, spent money on 3 movie tickets. So you have to take away 3 times the X, because X is the cost of a movie ticket, I should write a cost of a movie ticket. And you also spend $5.75 on a tub of popcorn. Okay. Now, again, you should simplify this. And in this case, I'm going to go ahead and ideally you put the variable in the front, although I do understand why you would want to leave this 40 on the front, because 40 is kind of like your starting budget. But because this is math, I'm going to go ahead and put the variable first, negative 3x. 40 minus 575, is that going to be kind of like 40 minus 6, which is 34, and then it's really 34.25. And yes, okay, negative 3x plus 34.25. If one movie cost $8, how much money did Tim have left? So it's kind of like the same exact style. Plug in the 8 back into x and see how much money he has left. Let's do negative 3 times 8 plus 34.25. And negative 3 times 8 is actually negative 24. Negative 24 plus 34.25 is a solid. Negative 24 plus 34 is 10.25 left over. Okay, so you have $10.25 in your budget still. And you think about it, if a movie ticket costs $8, that's $24 for 3. 24 plus 5.75 is $29.75, and you had $40 to start. Okay, I think these questions are pretty straightforward. I think if you just follow the directions, always define your variable before you begin, create a simplified expression as your second step, and then your third step is obviously with more details and more context. What do you do if the movie ticket costs $8 each? Okay, let's skip to something a little bit more challenging, and let's move to number 6. I think number 6 is that age-old question. Everyone loves these type of questions. I certainly like talking about them, and they're about coins. So it says, Molly has nickels, dimes, and quarters in her piggy bank. Okay, we all remember having a piggy bank growing up. She has twice as many nickels as quarters, and 15 more dimes than quarters. Molly has Q amount of quarters. Okay, so really, really good piece of information. The fact that we don't know how much she has, but we do know that she has a Q amount of quarters. Identify the unknown quantities. Write an expression that represents the total number of coins that Molly has in her piggy bank. Okay, so let's first say that Q equals number of quarters that Molly has. And how many dimes does she have then? Well, if we know that Q is the amount of quarters, 15 more dimes than quarters means she has more dimes, right? Whatever quarters she has, amount of quarters, she has 15 more than that in dime form. So Q plus 15 is going to equal number of dimes. Okay, so Q plus 15 is number of dimes. She has twice as many nickels as quarters. So she has twice as many nickels. She already has Q as quarters. She already has Q amount of quarters. So really twice is going to be 2Q, which is going to equal the number of nickels. Okay, so it's very, very important when you get a question like this, class. You want to make sure that you define each variable. Let's go backwards and review. Molly has Q amount of quarters. That's literally the first definition of a variable. She has 15 more dimes than quarters. 15 more means plus 15. That's the number of dimes. She has twice as many nickels as quarters. So literally, she has twice the amount of nickels as quarters. It's not saying twice the value. It's just saying the actual amount of nickels. So here, that's why 2Q. If Molly has 22 quarters in her piggy bank, how many nickels and dimes does she have? Okay, so it's kind of like saying Q is equal to 22. And that means D is going to equal 22 plus 15, which is 37 dimes. And that means N, which is nickels, is going to be 2 times 22, which is equal to 44 nickels. And then how much money does she have in her piggy bank? Well, this is where you're going to have to do some calculation. You're going to realize that she has 22 quarters. So 22 times 25 plus 37 times 10 plus 44 times 5. And notice how I kept things as a whole cent value. When you get your final answer, you have to realize that your answer is in cents. If you do want to put a decimal point as a 0.25, a 0.10, and a 0.05, you can. But I actually think that this is easier if you keep things in cents and then obviously convert at the end. 22 times 25 is going to be, is that 550? This is 370, right? 25 times 20 is 500. 25 times 2 is 50. So this is 550. And 44 times 5 is 220, right? So now you have to combine, and you could see which one's easier to add, although they're all pretty easy to add. So 550 plus 370 is at 620, 920. 920 plus 220 is going to give you a grand total of 1040. Oh, no, I'm sorry, 1140, right? And then 1140 cents means $11.40 in actuality. Okay, I thought this was a great question. You definitely want to review this. Now, obviously, I just did this, but I want to double check. So, um, you know, 22 times 25 is 500 plus. You always want to double check your work. 37 times 10 is 370. 44 times 5 is 220. 550 plus 370, that's 620. 920. 920 plus 220 is 940. 1140. Yeah, that should be right. Okay. Today was just an introduction of, defining your variable, following the order at which the information is given, and just paying attention to things like twice or 15 more or 3 times as many, kind of getting used to the language of word problems. And yeah, I think this is a pretty straightforward lesson. And let me know if you have any questions. Thanks for watching.